So hello guys, in this section of the course we will going to discuss how layer 3 routers automatically construct their layer 3 routing table. So our problem statement which we will going to understand in this section is that how L3 devices in the topology or network automatically knows where to forward the incoming traffic so that the traffic or data reaches to its intended destination via cooperation of L3 devices in the topology. The traffic must reach its intended destination via shortest path. So it is not like that L3 devices just forwards the packet or traffic so that the traffic reaches its intended destination. It is also important that the traffic must take the shortest path from source to destination in order to reach its destination. And there should not be any loop while forwarding the traffic, right? If there is a loop in the network, then the traffic exhausts the entire bandwidth of the network and causes the network outages. And we will going to understand what is equal cost multiple path, that is ECMP. So now let us try to understand these 4 points with the help of an example. Suppose you have a sample network topology here, you have a source device here and the destination device is here, right? You can see that the links in this topology is marked with some integer number. This is nothing but it is the cost of going from one device to another, right? So for example, the cost of going from the device S to this particular device is 10. So these are just integer numbers which is configured by the network administrator. These numbers are called the metric of the link. So this edge is called a link in network terminology, and the cost that is assigned to this link is called a metric, right? So the user configures these metric values to the link so that the administrator can control that what path the traffic should take in order to reach its destination from the source in the topology. So let us understand this point in little detail. So let us first try to understand the point number 1, that is the traffic reaches to its intended destination via cooperation of L3 devices. So suppose you have a router S and it wants to send the traffic which is destined to the router D, right? So the router S must have an L3 routing entry in its layer 3 routing table which says that, hey router, if you want to send the traffic to the destination D, then you must forward the traffic via this interface and not via this interface, right? Or not via this interface. Similarly, when this traffic reaches this particular router, this router again must have an L3 routing table entry in its routing table which dictates this router to how to forward this incoming traffic which is destined to the destination router D. So this router also looks up its layer 3 routing table entry and forwards the traffic as dictated by the layer 3 routing table entry. So let's assume that L3 routing table entry says to forward the traffic via this path. Similarly, when the traffic reaches this particular router, this router also forwards the traffic as per the layer 3 routing table entry in its layer 3 routing table. And finally, the traffic reaches the destination router D, right? So it simply means that the traffic reaches its intended destination from the source via cooperation of L3 devices. You can see that the router S and this particular router, they all forwards the traffic so that the traffic reaches to its intended destination. Suppose this particular router doesn't know how to forward the traffic, it simply means that the moment it receives the traffic from the previous router, it will black hole or it will block the traffic because it do not know what to do with the traffic, right? So even if one router doesn't know how to forward the traffic along the traffic path, the traffic would not going to reach its intended destination. So it simply means that the traffic reaches to its intended destination via cooperation of L3 devices together in the network topology. Then the second point says that the traffic must reach its intended destination via shortest path. Let us try to understand this point. Now in this topology diagram, you can see that from the source router S, there are multiple paths to reach the destination router D. The traffic can go via this path, or it can go via this path, or it can go via this path, and so on, right? So as the problem statement says that the traffic must be forwarded in the network topology from source to destination via shortest path only. It guarantees that the network resources are consumed minimal in order to accomplish the goal of sending the traffic to its destination. So can you spot what is the shortest path to reach from the source to the destination? You have to use this metric cost value that is assigned to the link in order to find the shortest path. So you can see that this particular path, that is 10, 10 and 20, it evaluates to 40, whereas you can see that the shortest path that reaches from source to destination is having the cost of 35, which is 10 plus 15 plus 10. Right? Similarly, another shortest path must be this one, right? Because its cost is also 35. Another shortest path is this one, because its cost is also 35. So if you notice that from the source router S, the destination D is reachable via 3 paths, and these 3 paths are ECMP paths, that is equal cost multiple paths. All these 3 paths have the cost of 35 to reach from the source to the destination. And hence, if the source router S sends the traffic or data to the router D, then that particular traffic stream will be equally divided along all these 3 paths. So guys, for the better visibility, I have redrawn the paths in green color, and these 3 paths are ECMP paths. So you can see what is happening at this point in this router, that as soon as this router receives the traffic from the source router S, it actually distributes the traffic along the 2 outgoing links, right? So the question is how this router gets this intelligence, how this router knows that the destination router D is reachable via equal cost multiple paths, right? Similarly, you can see that the router S is also forwarding the traffic out of 2 interfaces, because the router D is reachable via ECMP paths along these 2 outgoing interfaces, right? So this concept is called equal cost multiple paths. So this was the point number 3. And to understand the point number 4, you can see that each router in this topology which is forwarding the traffic always forward the traffic towards the destination D, right? No router in the topology bounce back the traffic to the predecessing router in this topology. So for example, suppose the source router S sends the traffic destined to the router D to this particular router. Now this particular router, if have an entry such that its routing table dictates that in order to reach the destination router D, send the traffic out of this particular interface. So it simply means that your traffic is looping. Router S will send the traffic to this particular router, whereas this particular router thinks that D is reachable if it sends the traffic out of this interface, right? So it simply means that this particular router has a wrong entry in its routing table entry, which creates a loop. So the question is that how it is ensured that every router in the topology has their routing table so constructed that there do not occur any loops. So let me take one more example in order to demonstrate that how loop can occur in a network topology. So for example, suppose the router S wants to send a traffic destined to the router D, and it has a layer 3 routing table entry which says that, hey router, if you want to send the traffic destined to the router D, you should send the traffic out of this interface, right? And let us assume that this particular router has an entry which says that in order to send the traffic to the destination router D, it should send the traffic out of this particular interface, right? Similarly, this router has an entry which says that to reach the destination router D, send the traffic out of this interface. And similarly, you have similar entry in this particular router, right? So you can see that this creates a loop in the network topology. This time the loop is a bigger loop, that is, it is happening in between 4 routers in the topology, right? So when the router S receives the traffic from this particular router, it again pumps the traffic back into the network topology, and the traffic goes into an infinite loop. So this ultimately exhausts the network bandwidth and resources unnecessarily, and therefore loops in the network topology is an undesirable, or in fact it's a very hazardous thing to have. So we will going to understand the algorithm which makes sure that routing table of the routers in the topology are constructed so that they obey all these 4 points.